obviously another stream, as you know, and another probability exercise. We've got numbers from 1 till 6, and with them actual 5-digit numbers being formed. Find the probability that the numbers of a number formed don't repeat, and the sum of the last 3 digits must be 13. Obviously, we need total number of cases and favorable cases. So, thinking about the total number of cases. Well, you know how it is. The total number of cases. You form a 5-digit number with a 6 number, so it should be C65. But then again, you can think of it like this: 5 circles, and in the first essentially circle, right, it can be 6 different numbers. And in the second one also, third one also. So it's essentially 6 at the 5th power, right? Yeah, I got it right. It's 6 at the 5th power. And after this, what? It's 6 of the 5th power. And now we calculate the m, basically, like whatever. Calculating them and moving over here. M is a favorable number of cases, and we have as 5 boxes. And we need our numbers to not repeat, so we've got essentially 5. I don't think it's 5 exclamation mark. This one's a bit harder, you know. What's here, bro? I have to really think about this. Well, let me think. So we can also work with C and so on. In the first 2, so the first one, C, you have 6 because you take out of 6 and 1. And the second one you have C of 5 and 1 because you already took 1 and they must not repeat. And I think that's the first 2 ones. So it's going to be essentially 6 times 5 for the first two ones. And next up, for the last three ones, our sum must be 13. So that's the harder part. Well, basically right here, it can either be, well, I don't really know which ones. It can be 6 and 4 and 3 and other ones like this is a bit hard, bro. 13 right there. So maybe I should start off with focusing on the last 3 digits. So the last 3 digits, right? Essentially, I can do like this. 13 sums, so it can be 6 and 5, which is going to be 11, and 2, 6, 5, 2. Or it can be also 6, 4, 3. And what else? Six, if I go over 2, I'll need, what? 8 plus what is 13? 6 to 5 also works, huh? And 6 and 1, that's 7, and I need another 6 for that, so it doesn't work. That sounds really hard, I don't even want to think about it more. So let's just see it. Six plus 5 plus 2. So we just have to write down all the fucking things. Okay, so essentially 6, 5, 2, right? That is one variant. And also we have 6, 4, 3. And 6. And that's it. Perhaps that's it. Okay, so in this case, the first two ones, right, can be mixed up, so 2 exclamation mark perhaps, so we don't repeat stuff like that. And for the last 3, you have the 6, which you're gonna take as a C of 4 because you already taken 2 before, and of 1, so 4 times everything 3 times 2, and or everything times 2, I don't really know. P3, so that's P3. Oh, fuck this, man. Okay, so that's that. We got binary Newton also there, perhaps. Times 2. Bro, times 2 for the 2 other numbers or what? For the 2 variants and what? Arrangements of 3 and 2, what? Arrangements of 3 and 2. Why 3 and 2? Why arrangement 3 of 2? P3 I kind of get twice. I guess for first things, the order matters, and you take out a 3 left for 2 things, bruv. It sounds hard, bruv. So we're gonna have that times 2, and right there, 3 exclamation mark divided by 2 exclamation mark, or not, so by nothing. And we're gonna have 6 times 2 times 6, so that is 72, right? And now we just place it all under the thing. And now 6 times, so basically 5 times. That, and we're gonna have bit simplified 3 right there. So 1 divided by what? By 3 times 36, which is 72, right? Oh, it's the first power there, or what? Oh no, it's 3 times 36, so it's not 2 times 36, so it's 108. Okay, that's that, and this one already seen how it's done. So I'm gonna have to find another video. Well, I watch this. I can watch this one. That's it, perhaps, on this channel. This one I remember. The third one I kind of remember how it was done. Geometry here. Okay, we can kind of watch this one. Understandable measure. So we have a shape ABCD 8, 8, 8, and goes down like this in M, 60 degree in A, find AD. So now we got a triangle like that, beam MA, so it's 90 degree in M, so we can apply the Pythagorean theorem, but we do not know anything there other than AB, so we can go over to C and also draw a line down, right? but we will know where 30 degrees, right? 30 degrees. So we can use the 30-degree formula, which means that AM is 4, right? And now we know that AM is 4. And if we draw a line down, okay, AM is 4. And we can apply Pythagorean to find BM. So BM is going to be the same as C and the line we draw down. So then we can apply Pythagorean there to find out what is that, and then we plus them out. That's what I think it is. AD essentially is AM plus BC plus this line. C what? CN? AM again, so they're the same. They're the same because this is kind of this shape, so we got essentially 16, right? So that's right there with 30-degree formula. I can skip this one. This one is with cos, so I'm going to skip this one. Limits obviously will be skipped, as well as integrals and stuff like that. Right. We have this exercise here, exercise number 11. There's a festival, and each of the 8 classes of a lyceum will show their culture, and there are 3 countries. The presentations are included randomly. Find the probability that presentations for these 3 countries will be kind of one after another, if you know what I mean. There are 8 classes in total, so 8 countries in total, so we want to know the probability that specifically these 3 countries will essentially basically be one after another. That is what we have to understand right now. So obviously, total number of cases and favorable ones. For the total number of cases, I would say, so for the total number of cases, we got 8 classes and they're all mixed up, so it's 8 exclamation mark, right? Yeah. Super G, the best. Now we got 8 squares. And the countries are denoted by a different color of a circle. That's how they're denoted. So to find the favorable number of cases, to find this, what we need to do is Exactly this. Let me think about it. So the rest of M5 it can be switched around, so 5 exclamation mark, right? Or stuff like that. But this three countries specifically, what can you do them? Um, so thinking about all the cases, it can either be 1, 2, 3, 4, 5, 6, 7 cases perhaps when they're placed together. Oh, man, it's hard, man. Maybe it's like 3 exclamation mark for the them and then times 7 and times arrangements of the rest. So the rest of them are 5. Whatever, man. Let me just see. Yes, they can be switched. 6 positions in total, looks like. 6 positions in total. All of them 3. So I got that right. I mean, kind of. And now we have to kind of note down the other stuff. Yeah, that's what I need to do. Note down the other stuff. How do I note it down? The rest of the 5 countries. What, 5 exclamation mark? I don't think that works. Maybe should be combinations of 8 and 5, right? Bro, what the fuck is this? It's not that. So it's essentially it's this, whatever. So that's 6 exclamation marks times 3 exclamation mark. Times 6. Yeah, because 3 exclamation mark is 6, so we got that, and then 8 exclamation mark below, so that's 8 times 7 times 6 exclamation mark, so we can, boom, 8 we can simplify. We're gonna have 2, 3 right there, 2, 4, 7, 2 and 2, done, so 3 by 28, that's the probability right here. Okay, so 3 divided by 28. Now, after this, last binom, Newton, stuff like that. Find the real values of x, for which the sum of a 4th and the 7th term on this fucking thing is equal to 1008. Alright, so the sum we can write down t4 plus t7 equal with 1008, right? 2 times 504, you decide to write down like this for now. And we just write down t4, we write down t7, and based on this expression find out what x is, right? That's what I can think about right here to complete this, right? C9 and 3y. Well, the power right there of expression is 9, so n is 9 always. And the 3 on top has the k, it has to be 3 plus 1, so it's 4, so corresponding to the term. Now we just pop the term, which is that whole expression at the power of n minus k, which is at the power of 6. And now the next thing, at the power of k, which is at the power of 3, obviously. A power of negative 3 or what? Well, power negative 3, he just popped it right now because he inverts the fraction, and now we have a negative power. And now plus the second thing, the T7 is going to be C9, and right there is 6 because 6 plus 1 is 7. And the same stuff, add the power of n minus k, which is going to be 3 right here. And once again, the same stuff, but a power of minus 6 right here. Yeah, add the power of minus 6. And all of that's equal with 2 times 504, which is essentially 1008. So I've got that. Now I can move forward with this. And should we actually solve the combinations right now? Perhaps. But maybe we'll leave them for later. Or maybe we don't even need them for now. We can just ignore them, as we need to work with x stuff. But perhaps we don't ignore them because we equal with all of that, so that's my logic right here. So now we should calculate the c, right? 987 because 6 exclamation mark below. That's simplified, so it leaves us with 3 times 2. And times right there 3 with a 3 exclamation mark. I mean 3 in front of the square root is going to be 3 at the power of 1 divided by 3 times that x. 3 at the power of x divided by 3 times that 6. 3 at the power of 6x divided by 3. And that is 3 to the power of 2x. Which kind of wasn't written out till the end now. And right there we get this. Essentially, the power of 3 just removes that. But we do have a negative right there, so negative 1. We pop it right there. Okay. Now working with that c, we're gonna have this one's a bit tougher. On top, it's gonna be actually kind of the same 789, right? 987, and below. So that's just C93, right? So 2 times 3. So very cool. Okay? So C93 and C96 is equal. And for the next thing, we just write down 3 to the power of x because the third power just removes the square root of a third order. And right there, minus 6 will removes that of a third order, but remains with minus 2, right, on the power right there. And right there we have essentially on the c, hold up, let's write down 2 times 504. So he basically split it like the 2 times 504 is that right here. Okay, now what we can do, we can work forward with a c, simplify it. We're gonna have 3 right there. Okay. And 4 right there. Boom. So that's 12 times 7. So how much is that? That is 84. It's been written out just like this, x2 right there. I don't know why he doesn't do it, he just keeps it like this. What, you're gonna keep that also the same? That is 3 to the power of minus 1 plus x. So it can be written out like this for some reason. I don't know why. And the next thing is also plus 3 times 4 times 7. 3 power of x right there. And right there, perhaps it's gonna be 3 to the power of x divided by 9 or what? 2x divided by 9. And all of that's 4. And 4 again, and 7 and 9. Yeah, I needed that. This simplified. This is 3 right there. And now what? 28 with 28. 3x with 3x. Free x with that x, and once again plus 3 x, right? Divided by 3. Okay, so we got that equal with essentially 36. So basically this resolution here is super geeky. 36 times 3. First one is gonna be 9 to the power of 3x. But actually we cannot multiply like this, so it's just 3 right there. Plus right there 3 like this. 3x equal with 4 times 9 times 3. Which is 27. So we can simplify the 3 with 27, or what? 4 times 3x. 4 times 3 to the power of 3x. Equal to this. Why? Because the 3x just kind of moves to the left and it's like multiplied again, so it's that. So the 4's are cancelled kind of. And 3x is going to be equal with 27, which is 3 to the power of 3, so 3x is going to be equal with 3, so x is going to be equal with 1. Jesus fucking Christ. That's super geeky. Okay, I'm gonna find something else good to watch.